So in this video, we'll concentrate on the rotation kinematics. So what do I mean if I say rotation kinematics? This is the type of the motion where it moves in the circular way, or I can say the circular motion. So we're looking at the something that is moving in the what? In the circular motion, or something that moves in the form of the circle. So that's the one that we'll be looking for today. So there is the connection between the rotation kinematics or circular motion and the linear motion. So let's first of all know which one is the linear motion and which one is the what? The circular motion. So when it comes to the linear motion, and this side, it's what we call angular motion. So when it comes to angular motion, we say displacement. But when it comes to angular motion, we say angular displacement. Like that. When it comes to the velocity, we say velocity in linear motion. But when it comes to angular motion, we say angular velocity. When it comes to the acceleration, we just say acceleration in linear motion, but when it comes to the angular motion, we say angular acceleration. So if you see that there are some differences in terms of the terms, even the calling of the terms, there are some differences, because here in the linear motion, it's just to say displacement, velocity, acceleration, or if we go into momentum, it's just the same thing. But when it's here, it's say angular what? Angular momentum. So if you even see that there's some differences, here we have the linear motion, this side is one of the what? Angular motion. So this type of the motion, which is in a linear motion, it's the type of the motion that only travels in the x-axis. So it travels like in a straight line. But when it comes to the angular motion, it's the type of the motion that travel in a form of the circle or in the angular ways like this. So when something is traveling now in the angular ways, it changes, it becomes what? Angular motion. It will shift from the linear motion to angular motion. So these are the main differences that we need to know. So how about if I say the units of the displacement in linear motion? The units or the SI units that we use for displacement or for distance in the linear motion, we find that are meters, like that. How about the velocity? The velocity are what we call what? Meters per second, like that. How about the acceleration? The acceleration is meters per second what? Squared, like that. How about momentum? Momentum is supposed to be k, then meters, then s second, like that. So it's supposed to be kgs, like that. Kgs, then m, then stroke s, stroke s, just s, like that, which is second. So those are the units that are in what? Linear motion. But when it comes to the angular motion, now we'll be looking at an angle. We'll be looking at an angle. For example, this is the point, right? This is the center. So for example, if the person moved from this point and he moved up to this point, so remember that he was moving in the what? In the angular motion. So if it was moving in the angular motion, we won't calculate the distance that it moved from here up to there. We are much concentrated on the angle that this person traveled from where? From here, this point which is here, to this point which is here. So how are you going to do that one? That's where you have to find the angle, which is this part, by saying the radius, which is the radius here, times again this is the radius. So you need to know the radius from the center to the point where it traveled, from this point which is here up to here. So that's how you calculate the what? The angular displacement. And this angular displacement, all the time when it is in the angular displacement, it's supposed to be what? Rad. So these are the units of angular displacement. So it's rad. How about the angular velocity? It's rad per second, like that. How about the angular acceleration? It's rad per second what? Squared, like that. So be familiar with the units, and also be familiar with the terms on how these terms are phrased, because sometimes they can say find the angular displacement. So it means that we're not finding something that is in the linear, but we're finding something that is in the what? Angular. So those are the differences that we need to know. So okay, let's also check on the formulas. So since I said that there's a connection between linear and the angular motion, so it means that there are also what? Connection in terms of the formulas. So if you remember, velocity final is equal to velocity initial plus acceleration times time, like that. How about the other one? We have the displacement final is equal to velocity initial plus 1/2 times acceleration squared, like that. What else? What the other one is final velocity squared final is equal to velocity initial squared plus 2 acceleration times what? The displacement, like that. And then the other one I can say displacement final is equal to displacement initial plus VIT, like that. So these are the formulas that we usually what? Use, right? Now, I want you guys to understand a bit here. Now, we have to know also the symbols of these, right? So, the symbols. So I'll take that this point, which is this point, this part is linear here. Linear what? Symbols. I also take this part as the angular symbols. So if you look at this, you have the linear symbols and also the angular symbols. So when you talk about the velocity, okay, let's start with the displacement. When you're talking about this displacement, the symbol of the displacement is what? X, like that. How about the symbol of the displacement in the angle? So it will change to be the theta, like that. How about the symbol for velocity? It's V, like that. How about when it comes to the angular, it changes to omega. How about the acceleration? The acceleration, it's A in this point, but when it comes to the angular, it changes to what? To alpha, like that. So these are the symbols that you need to know and you need just to be familiar with. So the displacement, it changes to theta. The velocity, it changes to omega. Then the acceleration, it changes to alpha. So those are the differences that you need to know. So remember the formula that we have here, which is the final velocity is equal to initial velocity plus acceleration times time. So in this situation, what are you supposed to do? Let's change these formulas now to what? To the angular motion. So meaning that here to be what? Omega final is equal to omega initial plus alpha times t. So we have converted the formula, which is this part. Now we have converted it now to what? To the angular. This part, it was in the linear, but now the other part, it has changed to what? To the angular. So let's change the second one, which is this one. So this is the first one, and this is the second one, and this is the third one, and this is the fourth one. So let's change the second one. So how are we going to change the second one? We're going to say, remember that's a displacement. So if that's a displacement, meaning that it will change to be what? To be theta, which is theta final, then alpha or omega initial times t plus 1, which is half, times alpha times t squared, like that. How about the other one? The third one, just the same. It will be omega squared, then omega initial squared plus 2 alpha, then that displacement changes to what? To theta, like that. How about the other one? It will changes to what? It will be theta, that's a displacement final, is equal to displacement initial. Now that's the angular displacement. And the other one to be what? Omega initial times t. So this is how you change these formulas. Now we've taken these formulas now to what? To the angular motion. So that's how you what? You change these formulas. So what is another thing? The another thing is when you're converting, right? When you're converting from the linear, okay, let's start with when you're converting from the linear to when you're converting from the angular to linear. So if you have been given something like they ask you to convert from the what? From the angular to linear. Most of the time they usually ask in this way, like tangential, linear, something like that. So if, for example, if they say tangential or tangential velocity, or if they say tangential acceleration. So if they say tangential velocity, if they say tangential acceleration, what do we really mean in this situation? So in this situation, they are asking us to calculate the velocity that the velocity that is in the what? In the linear motion. So which formula are we supposed to use in this situation? That's what we're about to do. So now we are converting from linear to angular. So we're converting from what? Linear to what? Angular. So in this situation, we say theta is equal to displacement over radius. How about the other one? It's our omega velocity over radius. How about the other one? We have the alpha is equal to what? Acceleration of what? Radius. So those are the things that you need to what? To take note of. Now, how about if you're converting from the angular motion to linear motion? So in this situation, we use this formula, which is it? Displacement. This S that we are seeing, it's a displacement. Okay, so to avoid much confusion, let me just what? Use the displacement, which is X like that. So displacement X like that is equal to R theta. So meaning that we are converting from the what? The displacement from the angular to the linear. So how about when you're converting from the velocity, from which is the angular velocity to linear velocity, we use this one. We use this one, which is R like that. How about this one? It's acceleration is equal to alpha times R. So in this situation, we use this formula if you've been asked to calculate the what we call tangential velocity. That's the one. How about this one? This one, we use this one if you have been asked to calculate what we call tangential acceleration. So those are the things that you need what? To take much time to, right? So okay, so I've explained about if you're converting from linear to angular motion, these are the formulas that you use. If you're converting from the angular motion to linear motion, these are the formula that you use. Sometimes they'll say tangential velocity, this is the formula that you use. Tangential acceleration, this is the formula that you use. So those are the main issue. So now let's do about the next part about what we call centripetal force and what we call centrifugal force. So we have an object that is moving in the circle, or that is moving or on the roundabout. So remember that if we have an object that is moving here, meaning that there are two forces that are acting on this object. There is a force that is making this object to move away from the center, and there's a force that is making this object to move close to the what? To the center. So the force that makes an object to move away from the center and the force that makes an object to move close to the center are this force that makes an object to move away from the center. It's what we say centrifugal force. And the force that makes this object to move close to the center, that's what we call centripetal force. So centripetal force is the one that makes an object to move close to the center, and the centrifugal force is the one that makes an object to move away from the center. So how do you calculate this type of the forces? We calculate this type of the forces by saying force is equal to force is equal to mass times what? Acceleration. So it will be mass times what? The acceleration. The acceleration at which this object is moving. The acceleration at which these objects are what? Are moving, or angular velocity, or angular what? Or angular acceleration in short. So how do we find this acceleration? We calculate this acceleration by saying acceleration is equal to what? V squared over radius. Which radius? The radius that is here. So this is how we find the what? We find this stuff. So the next part we'll concentrate on the what? On the questions.